So our group, the squad, consists of 5 members, which are Laila Atira, Putri Aina Atira, Mushida, me, myself, Nur Zulaika, and also Nurul Azira.
Let's get started with the introduction of logical connective. Logical connective is a symbolic logic studies some parts and relationships of the natural language by representing them with symbols. The main components of symbolic logic are statements and connective. A statement or a proposition is a declarative sentence that is either true or false, but not both. The truth or falsity of a statement is called truth value. Statements are usually denoted by letters P, Q, R, S, and so on.
Primitive statement. A primitive statement will consist of only a statement in which it has one subject and one predicate. It also known as primary statement or simple statement. The primitive statement is represented by a variable such as P or Q or R or any variable in small letter. Next, logical connective and compound statement. As we can see, this is the table for logical connective compound statement and symbolic compound statement. The first one is conjunction, the second one is disjunction, the third one is conditional or implication, and lastly is for biconditional. Next, truth value and truth table. A true value is the true or falsity of a statement or proposition. The truth table displays the relationship of the true value of the statement. If the compound statement has two variables, let's say as P and Q, then the truth table must be constructed with 4 rows. If the compound statement has 3 variables, let's say as P, Q, and R, then the truth table has 8 rows. It can be simplified into the formula below, which is 2 power of n, where n is the number of variables. Next, a truth table summarizes all possible true value of a statement. For example, a statement P can only either be true or false. And for example, we use digit 1 and 0 for true value. As we can see, this is the table for true value and truth table. Next, negation. The negation of statement P has an opposite true value from it. The negation of a statement P denoted by not P and it is read as not P. The true value of the negation of a statement satisfies the following property. Like, if P is true, then not P is false, and if P is false, then not P is true. As we can see, the following table shows the property of negation, which is P false and not P is true. If P true, then not P is false. Next, conjunction. This conjunction is used to combine any two primary statements by the word and to form a compound statement. The conjunction of two statements P and Q is denoted by P and Q. If P is true and Q is true, the P and Q is true. Otherwise, P and Q is false. The following table shows the property of conjunction, which is P false, Q false, P and Q is false. And if P false, Q true, P and Q is equals to false. If P true, Q false, then P and Q is false. If P true, Q true, then P and Q is true.
Disjunction in bracket or used to combine any two primary statements by the word or to form a compound statement. The disjunction of the two statements P and Q are denoted by P or Q. The true value of the compound statements P or Q satisfies the following property. If P is true or Q is true or both P and Q are true, then P or Q is true. Otherwise, P or Q is false. We need to make a truth table for P0011, Q0101, and P or Q0111. For conditional statement, a compound statement of the form if P then Q, write it symbolically as P arrow Q. P equals to antecedent, which is hypothesis, and Q equals to consequent, which is conclusion. The true value for conditional if P then Q satisfy the following property. If P is true or Q is false, then the conditional if P then Q is false. Otherwise, if P then Q is true, we need to make a truth table P0011, Q0101, if P then Q1101. Next, for biconditional statement, the symbol left right arrow and P left right arrow Q is often read P if and only if Q. This statement equivalent to if P then Q and if Q then P. The two statements have exactly the same true values or truth tables. The true value for biconditional P if and only if Q satisfy the following property. If P and Q have the same true value, then P if and only if Q is true. If P and Q have opposite true value, then P if and only if Q is false. We need to make the truth table for P0011, Q0101, P if and only if Q1001. Truth table P if and only if Q if we use conditional statements approach. P0011, Q0101, if P then Q1101, if Q then P1011, if P then Q, and if Q then P1001. Next, let's move to tautology, contradiction, and contingency. Firstly, tautology. Tautology is a statement that is always true regardless of the circumstances. Check whether the statement is a tautology by using truth tables. My favorite food is chicken, whether it is fried or not. In symbolic form, P or not P. P equals to my favorite food is fried chicken. The truth table for the statement is P01, not P10, P or not P11. Next, contradiction. Contradiction is the assertion of a statement and its negation, or equivalently a statement that can never be true. A contradiction is equivalent to the negation of a tautology. We need to create the truth table P01, not P10, P and not P00. We show the statement P and in bracket P or Q is a contradiction by using the truth table P0011, Q0101, P or Q0111, not in bracket P or Q1000, P and not in bracket P or Q0000. Lastly, contingency. Contingency is the true values contain both true and false. The following example shows an example of contingency. We need to make a truth table P0011, Q0101, not Q1010, P and in bracket not Q0010, if P then Q1101, not in bracket if P then Q0010.
Okay, next we will continue with the example. For example 1, you need to represent the following statement using logical connection. And this is the question. If the lasagna is cold, then the pizza will be delivered. Either the lasagna is cold or the pizza won't be delivered. If the pizza won't be delivered, then both the stromboli is hot and the lasagna is cold. The lasagna isn't cold if and only if the stromboli isn't hot. The pizza will be delivered only if the lasagna is cold. The stromboli is hot and the lasagna isn't cold, but the pizza will be delivered. Next, we need to label the sentence. For the sentence, the stromboli is hot, we need to label it as S. The pizza will be delivered, we need to label it with P. And the last one, the lasagna is cold, we need to label it as L. And this is the answer for the sentence A. The stromboli is hot and the pizza will be not delivered. And the symbolic will be as conjunction not P. If for sentence B, if the lasagna is cold, then the pizza will be delivered. the symbolic will be L, conditional P. For C, either the lasagna is cold or the pizza won't be delivered, the symbolic will be L, this conjunction not P. For D, if the pizza won't be delivered, then both the stromboli is hot and the lasagna is cold, and the symbolic will be not P, conditional in bracket S conjunction L. For E, the lasagna isn't cold if and only if the symbolic if and only if the stromboli isn't hot, and the symbolic will be not L, by conditional, not S. For F, the pizza will be delivered if sorry, for F, the pizza will be delivered only if the lasagna is cold. The symbolic will be P, conditional F. And the last one, for G, the stromboli is hot and the lasagna isn't cold, but the pizza will be delivered. The symbolic will be S, conjunction, not L, conjunction P.
So for the second example, the question asks us to write this statement into primitive statements using P, Q, and R, and write it in symbolic form using logical connective and construct a truth table. The statement is, if you can access the internet from campus, then you are a computer science student, or you are not a first year student. There are two logical connectives in this statement, which are conditional, which is if and then, and disjunction or. So this is the answer for this question. P, you can access the internet from campus. Q, you are a computer science student. R, you are a first year student. So in symbolic form, P implies in bracket Q or not R. So this is the truth table for this question. So we can see that the proposition or the statement is contingency because the truth value for P implies Q not R contain both true and false value.
Let's move to example 3. The statement given is P and Q in bracket implies R in square bracket, or P biconditional with R. The question wants us to determine whether the proposition is tautology, contradiction, or contingency using the truth table. So, this is the truth table for the statement. We must do the table and put the symbol to get the last compound statement. First, we put P, Q, and R. For P, false, 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 true, 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 true. Q, false, false, true, true, false, false, true, true. And for R, false, true, false, true, false, true, false, true. Let's move to symbol P and Q. To get the answer, we must look at P and Q. If P and Q have one false, then the statement is false. If P and Q is true, the statement is true. Next, P and Q in bracket implies R. If P and Q result is true and R is false, the result is false. Otherwise, the result is true. For P biconditional R, if P and R have same value like true true or false false, the result is true. Otherwise, the statement is false. For the last one, P and Q in bracket implies R in square bracket, or P biconditional with R, we must look at statement we got we must look at the statement we got from early, and we got the result is true, 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 false, true. So, based on this truth table, we can know that statement is contingency. For the conclusion in this topic, we use symbol to stand for the relationship between statements. These relationships are made between by logical connectives such as conjunction, disjunction, negation, and conditional. Connectives are used in compound statements, each of which compose at least two simple statements. Lastly, a statement is a sentence that can be either true or false.